Good day everyone! In this video, we will discuss about the transformations of the graphs of exponential functions. We have defined exponential function as a function that can be written in the form f of x equals b raised to x, where b is greater than 0, b is not equal to 1, and x is any real number. Moreover, we have also discussed the properties of the exponential functions and their graphs, and these are the following. Let f of x be equal to b raised to x, where b is greater than 0 and b is not equal to 1. Domain is the set of values of x, wherein x is an element of real numbers. Range is the set of values for y, where y is greater than 0. If b is greater than 1, then f is increasing. If b is greater than 0 but less than 1, then f is decreasing. The function passes through the point 0, 1, since f of 0 is equal to b raised to 0, which is equal to 1. The graph is asymptotic to x-axis. To discuss the transformations of the graphs of exponential functions, we will use the function f of x equals 2 raised to x as our mother function, and we will compare graphs of other exponential functions from this graph. Recall that we have also discussed that in graphing exponential functions, it will be a great help if you will make a table of values and plot the resulting ordered pairs on a Cartesian plane. The graph shows three exponential functions. The red one is the graph of the mother function f of x equals 2 raised to x. Moreover, the blue one is the graph of f of x equals to quantity 2 raised to x. Comparing it to the mother function, it is vertically stretched. On the other hand, the green one is the graph of f of x equals 1/2 quantity 2 raised to x. And comparing it again to the graph of f of x equals 2 raised to x, it is vertically shrink. From the previous illustration, we can conclude that when exponential function f of x equals b raised to x is being multiplied to a constant c, the graph will either vertically stretched or vertically shrink. Vertically stretching will happen if the multiplier c is greater than 1. On the other hand, vertically shrinking will happen if the multiplier c is greater than 0 but less than 1. On this one, the illustration shows graphs of three exponential functions. Again, the red graph represents f of x equals 2 raised to x. The blue one is the graph of f of x is equal to 2 raised to x plus 2. Notice the difference between the two functions. In the new function, we have added 2 in the exponent, and the graph translated to the left by 2 units as well. Moreover, the green graph represents f of x equals 2 raised to x minus 2. Comparing this graph from the red one, this graph was translated 2 units to the right when we have subtracted 2 in the exponent. What happened to the graphs earlier is called horizontal translation. It means shifting to the right or to the left. This happens when we add a constant c to the exponent. The graph shifts to the right when c is less than 0 and shifts to the left when c is greater than 0. In this illustration, the blue graph represents f of x equals 2 raised to x plus 2. And notice that from the graph of f of x equals 2 raised to x, it was shifted 2 units upward when we added 2 on the function. Likewise, the green graph represents the function f of x equals 2 raised to x minus 2, which was shifted 2 units downward from the graph of f of x equals 2 raised to x when we subtracted 2 from the function. What happened to the graphs earlier is called vertical translation. It means shifting upward or downward. This happens when we add a constant c to the function. The graph shifts upward when c is greater than 0 and shifts downward when c is less than 0. In this illustration, the blue graph represents the function f of x is equal to 2 raised to negative x. See that the graph of f of x equals 2 raised to x was reflected with respect to y-axis when the exponent was negated. On the other hand, the green represents the function f of x equals negative 2 raised to x, which is a reflected image of f of x equals 2 raised to x when the base was negated. The transformation happened to the graphs earlier is called reflections. This happens when the base or the exponent was negated. When the base is negated, then the reflection is about the x-axis. But when the exponent was negated, the reflection is about the y-axis. I hope that you have understood the lesson. For the next video, we will discuss about the domain and range of exponential functions. Thank you for listening and see you on our next discussion.